For section 6.5, we're going to be dealing with the law of sines. This section deals with law of sines. The next section will deal with law of cosines. These are both used when we have oblique triangles. That is a triangle that doesn't have a right angle in it. We can still use trig, it just gets a little more funky because there is no hypotenuse, opposite, all that stuff. So law of sines is actually fairly simple. It's the sine of the angle over the side opposite. So sine A over side opposite, that's equivalent to sine of B over side B, etc. You're going to use basically two of these three to set up a proportion and solve. So it might be that you do these guys, or it might be that you do these ones, something like that. Now, when do we use it? We use it in cases where we have angle side angle. So if we have an angle, the side in between, and another angle, or when we have angle, angle, side, we have two angles and a side that's not between them. The third case has an asterisk on it because it's the ambiguous case, which we'll talk about. It is if we have angle and then two sides, and the key component here is notice that the angle is not between the sides. This is, again, the ambiguous case because this could lead to 0, 1, or 2 triangles. Now, this section and the next one will be using our calculators, but I will show you how you would express an answer on a quiz or exam when you don't have a calculator. So solving the triangle, that means finding out all the information. So I'm given side A, lowercase a, so that's the opposite of angle A. I'm given angle A of 79 and angle B of 62. So the case we have here is angle, angle, side. Two angles and the side that's not between them. That means I'm going to do law of sines. So I'm going to set up a proportion with the info that I know. I know that (79°) sine 79 matches with the side opposite, which is 31. And I'm going to set up a proportion with that equal to, well, the only other information that I have is angle B. So I'm going to say sine of 62 over B. I'm having some trouble with the pen, apparently. That's a little better. So again, side B is opposite of angle B, lowercase b. So to solve this, I'm going to cross multiply. When I do that, I'd have B sine 79 equals 31 sine 62. And then I would divide by B, I'm sorry, not divide by B, divide by sine 79 to get B by itself. So on a quiz or exam, excuse me, yes, a quiz or exam, that is how you would express your final answer. 31 sine 62 all over sine 79. On the homework, it's going to ask you to actually calculate it out. So from here, we'll just be putting that into a calculator. Make sure you're in degrees. You should get side B to equal 27.88. Now remember, this is solve the triangle. We still have more information to figure out. I didn't get the missing angle, but that's easy enough because all the angles add up to 180. So if you add up the angles you have, subtract from 180, you'll get that your missing angle C is 39 degrees. So again, that is one of my pieces of information. Now I'm only missing side C. I can set up another law of sines to do this. So I'm going to go with, for my first ratio, I'm going to go with this one because those are exact numbers. If I use angle 62 degrees, I would be using a rounded side. So I don't like that since I rounded that, and I might be wrong anyway. So again, I'm going to go back to the ratio sine 79 over 31. Now I'm trying to get side C this time, so it's going to be sine 39 over side C. You would do the same cross multiply and all that fun stuff, and you should end up with rounded about 19.87. For number 2, we're going to draw the triangle. I usually draw the same generic looking triangle regardless of if it's accurate, and I call it ABC. Fill in my given information. I know side C is 230. Angle A is 50. Angle B is 68. So this would be the case of angle, side, angle, which is law of sines. Now on this one, I do have to find the missing angle first because the only side I have is side C, so I need angle C. So if you do 50 plus 68, subtract from 180, you'll get angle C to be 62 degrees. And again, that is one of the pieces of information I was trying to find. So now I can set up law of sines. So this would be sine 62 over 230 equals, let's say I want to solve for side A. Doesn't really matter which one I pick. But if I want side A, it's going to be sine 50 over A. Cross multiply. A times sine 62 equals 230 sine 50. Divide over the sine 62. And again, show one more time, this is how you would put it in your calculator. So this would be the answer on a quiz or exam. And if you throw it in your calculator, we'll go to 2 decimals again. I'd have 199.55. The only thing I'm missing now is side B. I'd start off with the same first ratio, sine 62 over 230, but this time I'm going to set that equal to sine 68 over B. If you do the same stuff, you'll get side B equal to 241.52. Next, we're going to talk about what's called the ambiguous case. Angle side side may result in 0 triangles, 1 triangle, or 2 triangles. We'll figure out how to determine that mathematically in just a little bit. But I want you to kind of see what's happening here. Here is basically the angle side side case. So I'm given an angle, a side, and this would represent the other side. So right now you can see this shows no triangle. This side A here is not long enough to create a triangle. It could create two triangles though, which would be this inside triangle, the shaded one, and the big full triangle. So that's an example of two triangles. Or it could only make one triangle, something like this. So it's ambiguous, but through the calculations of using law of sines, we can figure out which one we have. So this first one will be a no triangle, but we're going to see why. So if I draw out my generic triangle, fill in the information. I have side A, side B, angle A. This is angle side side. I have to be able to set up a proportion with law of sines. So the only thing I can do is sine 42 over 70. Now this one's going to be different than what we've seen. Sine B, capital B for angle B, over 122. Still going to cross multiply. So this is going to be 122 sine 42 degrees equals 70 sine B. If I divide by 70, so that clears out that 70. Here's the hitch on this. I haven't done this yet. I have to now do the inverse sine to get B by itself. We're using inverse trig. Remember, inverse trig gives me angles. So I would have to do the inverse sine of both sides. So inverse sine would cancel out sine technically. And so the inverse sine of all of that mess is what I would put in my calculator. And if you do that, inverse sine of all of that, so it'd have to all be in a parentheses or something. You have to figure out how to do it on your calculator. It should give you an error, which means there's no triangle here. So figuring out no triangle is pretty quick. Your calculator says, no, you can't do this. What about if there's one triangle? So again, angle side side, I'm going to do the same thing. Sine 40 over 10 equals sine B over 7. I'll show one more time how I isolate angle B. So I'd cross multiply. I would divide over the 10. And then I would take the inverse sine to get B by itself. So I'd really be doing the inverse sine of 7 sine 40 over 10. If you put that into your calculator, you should get that angle B is 26.74 degrees. So I got an answer. What does that tell me? That tells me that there is at least one triangle. I'd have to check to see if there's a second one. So here's where it gets tricky. The other option for angle B is going to be 180 minus the angle I found for angle B. That is the other option. If I do that, that gives me 153.26. Again, this is the other option for angle B. But within the context of the problem, that's impossible because 153 and the other angle that's set at 40, that puts me over 180 degrees overall. I know that all three angles are supposed to add up to 180. I can't already be over 180. So that tells me the other angle B option does not work. So there's only one triangle. I now have two of the three angles. I have the 26.74 and the 40. You can figure out the missing angle C to be 113.26. And now, unfortunately, you're going to have to use that angle to figure out side C. So I'm going to go back to my original ratio, sine 40 over 10 equals, now I'm doing sine 113.26 over side C. That's the normal stuff. We cross multiply, we get C by itself. You should get side C to be about 14.29. The last case is two triangles. So we still started off the same. Draw myself a little triangle. If I set up my law of sines, sine 37 over 30 equals sine B over 40. I'm not going to go through the steps, but you'd cross multiply, and eventually you'd have to get B by itself by taking the inverse sine. You're going to get B equal to 53.36 degrees. So that tells me there's at least one triangle. Now, obviously, this is two triangles because I told you it was, but we usually wouldn't know that. So now I have to test the other option. So again, the other angle B is 180 minus the first angle that I found for it. If I run those numbers, I will get the other option for angle B to be 126.64 degrees. Now, this one is feasible because 126.64 plus 37 does not put me over 180. That means, yes, there is another option. So for this problem, that means that I've got two triangles. So I'm going to call the first B that I found B1, and the second B I found B2. So fun, you get to do two problems within one. You get to solve two triangles on this. So I would consider drawing another, so this is the B1 triangle. I would draw another triangle with the same given information. And so we know this one is the 53 angle. I'm not going to write all the decimals, but I know that's the 53 angle on B1. This other triangle is B2. And that's got the 126 angle in it. Oh, I've got my other given angle. And you'd have to solve both of them. So you'd have to find two angle C's. So there'd be a angle C1, which I would be using the top triangle. Add them up, subtract from 180 to get that angle to be about 89.64. And there'd be a C2 angle based off of this triangle, which is 16.36. And then you'd still have to find side C on both of those. So you get to set up another law of sines and solve for your side C on both, which I'm not going to set up. We've done several times. But on the first triangle, side C is 49.85. And on the second one, side C is 14.04. So fun. You get to do it twice over. I believe there's one problem on your homework where you're going to have to do that. So that one's going to take a little while. It's a lot of button mashing on the calculator. We're actually going to not worry about number 6. We're going to go to number 7. You don't have one like number 6 on your homework. We had a similar problem to this when we were doing just right triangle stuff, but now we can do this with law of sines. My big red triangle here is what I'm looking at. So we've got a pilot flying over. I have two angles of depression. I know those two markers, the A and B markers, are 5 miles apart. So the first thing it wants is the distance of the plane from point A. Well, what I can first use is a property back from geometry. That angle 32 degrees is equal to this angle down here. They are alternate interior angles. So I know that this angle is 32 inside of my red triangle. By the same logic, angle B is 48 degrees. Using this big triangle, angle C then, I'll call this C up here, is 32 plus 48, subtract from 180, you get 100 degrees. So the first thing it wants is the distance from the plane to point A. So that would be side B of this red triangle. I can set up a law of sines. This is going to be sine 100 degrees. It's a terrible 100. Over 5 equals sine 48 degrees over B. You cross multiply. Again, if this was a quiz or exam, you'd end up with 5 sine 48 over, let's see, that'd be over the sine of 100. And that'll give you side B. Which on this one will be about 3.77 miles. Okay, so that was the first part. Done. Part B is what is the elevation of the plane? Well, for part B then, I want to know how high up this plane is. Now I can go to right triangle trig. So now focus on this green right triangle. I know that side B, I just figured that out, is 3.77. So using the 32 degrees, I want to know the altitude. I'll call it, or the elevation, I'll call it E. I can use just regular sine, not law of sines here, because this goes back to right triangle trig. So I can say the sine of 32 equals elevation over 3.77, opposite over hypotenuse. And if you multiply 3.77 over, you'll get the elevation is pretty much exactly, or rounds to 2 miles.